Classroom, Bill Keneely here alongside Declan Cannon today. And today's topic, dealing with our tropical systems, will go on through the depressions and the storms as well as the hurricanes. And seeing as we are now into wintertime, we'll talk about the arrival of winter and how it all plays out with the planets and also the sun angle over North America especially. Today's focus, though, again dealing with the tropics. We'll talk about, first off, the hurricanes. Over a 100-year period, they tend to peak right around the 10th of September, and you can see then they tend to trail off, maybe a little peak there in October, but then they really do trail off. So what we're dealing is really September 10th, about the period of the very warmest water temperatures over the northern areas, especially in the equatorial zones, say between the Tropic of Cancer and the equator itself. That is where we usually get our formations as we have trade winds that blow, and these trade winds coming out of the northeast and southeast, they collide, and that forms the intertropical convergence zone. We get these clusters of showers develop, and when they assume a circulation, getting that counterclockwise flow, they become a tropical disturbance, and when they get winds less than 39 miles per hour, they actually become a tropical depression. That is how they are classified. Now, the winds do increase, and as they do, they tend to become circulatory right around the center itself, and our system looks more circular in nature, some bands coming into it, and these winds can be as high as 73 miles per hour. Then you have the full-blown hurricanes, typhoons in the Pacific, at least in the western Pacific. And again, with the hurricane itself, you have your highest winds right there, right near the eye wall, running better than 74 miles per hour. Then you have what we call spiral bands, and they also have very gusty winds. So again, you need very warm water, and you need these disturbances, circulations develop, and if everything is right, you get a hurricane, and they tend to migrate their way westward and then northward across the western Atlantic.
A large percentage of hurricanes that affect the United States normally form miles from the coast in the Atlantic Ocean. The Weather Channel's Jim Cantore has more.
Hurricanes can be very destructive and deadly. Hurricane Hugo caused nearly $10 billion worth of damage and 49 lives lost. Andrew ripped through South Florida and Louisiana, causing an estimated $30 billion worth of damage, and 54 people lost their lives. The storms normally pick up in intensity as they steam across the ocean. A hurricane is a vast heat engine. The fuel is the warm ocean water. It feeds heat and moisture into the air, getting sucked into the center of the storm. Some of the incoming air rises into the spiral rain bands that surround the storm's core. As warm air reaches the eye wall, it rises rapidly and condenses into clouds of rain. The rising air releases tremendous amounts of heat into the atmosphere and creates violent winds. In this way, the hurricane's engine is constantly refeeding itself, concentrating its power in the wall of clouds surrounding the storm's eye. The eye wall contains the hurricane's most destructive power. The winds can cause extensive damage, as witnessed during Hurricane Hugo and Andrew. Jim Cantore, the Weather Channel.
In order to find out exactly what a hurricane is doing, we have to fly directly into the storm. We'll have a look now at what those planes actually do.
Cloud cover is sparse. One of the C-130 Storm Tracker planes based in Biloxi makes a reconnaissance training flight. Preparation starts in the early afternoon as the 8-man crew goes through a detailed briefing. The mission can be dangerous, but the crew has complete confidence in their transportation.
C-130 was built for cargo transport, short field landings, and it gives us a good capability for flying into the storm. We fly directly through the side of the storm, penetrating the eye wall.
When in the air, the plane sends information to the Hurricane Center on the progression of storms by dropping sophisticated measuring devices. As the cylinder descends through the clouds, it measures the air temperature, pressure, wind speed and direction, and sea surface temperature.
That information is used to help them determine where the actual storm is, what the storm is doing. We are data collectors. We don't try to predict where the storm is going. We simply collect the data for them.
The plane and crew are always on standby, and they are a vital part of the information gathering process to help save lives and property in the event of a landfalling hurricane. I'm Jim Cantore, the Weather Channel.
Now, actually, when we gauge the strength of the tropical systems, we have what is referred to as the Saffir-Simpson tropical cyclone intensity categories, and they run from 1 to 5. You can see the wind speeds according to each category have been posted. I'm going to get out of the way. Not listed here is also the associated storm surge, which occurs with some of these particular categories. Now, you notice Category 3 at 111 mile-per-hour winds as the entry level for Category 3, all the way up to 130 miles per hour. As you look now, as we go back over the last 5 years, if we were to say what are some of the more significant tropical systems that have affected the eastern United States, 1989 saw Hurricane Hugo. This is a plot of Hurricane Hugo's course, and at the time, these were the Saffir-Simpson scale intensities. We had the Category 2, 3, and as it approached the South Carolina coast, you can see Category 4. Also in the news, of course, in South Florida, in 1992, Hurricane Andrew, as it tracks west, increasing along the westward-bound track from a Category 2, 3, and 4. Well east of Florida, it was a Category 4 already at that time. Here's more on the Saffir-Simpson scale with Dale Eck.
Hurricane Camille devastated the Mississippi Gulf Coast in 1969. Winds were estimated in excess of 200 miles an hour. Hurricane Jerry hit the Texas coast in 1989, a much weaker storm, but it still managed to cause damage. There is a way to measure the strength of a hurricane. It's called the Saffir-Simpson scale. It is based on the factors which combine to give a hurricane destructive power. These factors include the level of the air pressure, the speed of the winds, the amount of water pushed onto the land by the storm, known as the storm surge. The scale ranges from 1 to 5, 1 being a minimal and 5 being catastrophic. It is the storm surge which primarily causes the damage and deaths in hurricanes. By knowing the Saffir-Simpson scale rating for a hurricane and by listening closely to hurricane watches and warnings, you can protect your property and your life. I'm Dale Eck, the Weather Channel.
In weather history today, we focus specifically on August. 1985, residents along the northeastern coastline were evacuating their homes as a powerful hurricane headed their way. Bill Keneely takes a look back.
Several days before landfall, Hurricane Gloria was one of the most powerful hurricanes observed in the Atlantic Ocean. Gloria did lose some of its intensity as it passed just to the east of Cape Hatteras on September 27th as a Category 3 hurricane. Farther to the north, residents and officials were preparing for the storm.
This is the Yarmouth Police. The hurricane is on its way and you are advised to evacuate to the nearest shelter.
Mandatory evacuations were in place for many coastal areas. Atlantic City was closed down as business owners boarded up their properties and headed inland. The Weather Channel tracked the storm as it headed towards the northeast. First landfall came at Fire Island in New York with winds up to 115 miles per hour. Second landfall came in Connecticut with winds still up to 110 miles per hour. The winds caused extensive damage. Trees and power lines were blown down on the coast. Coastal flooding was also a problem as high seas crashed over the seawalls. Hurricane Gloria killed 8 people and caused damage of nearly $1 billion. I'm Bill Keneely, the Weather Channel. Seeing as it is the first day of winter, we thought we'd take a little retrospective. Wintertime did arrive at 3:26 p.m. Eastern Standard Time, or about noontime Pacific Standard Time on this date. And what happens, what we have now, is our situation where the sun angle, the sun is directly overhead, not over North America, but well on down to the south. It's actually overhead down around the Tropic of Capricorn. That's about 23.5 degrees south latitude. You remember, once we get to the first day of spring and the first day of fall, the sun is directly overhead right at the equator. And the first day of summer, we are tilted towards that sun, so it's a lot hotter, obviously. And the sun is directly overhead right there at the Tropic of Cancer. But this time of year, we are definitely looking at a very thin sun angle. That's why the air tends to be much, much colder. And again, our jet streams drop down and the threat of snow increases over a lot of North America. To find out more regarding the tropics, check out Chapter 12 in the Weather Classroom.
The Weather Classroom is a production of the Weather Channel. To order the companion book for the Weather Classroom, send $9.95 plus $3.95 shipping and handling to the Weather Channel Education Services, 2600 Cumberland Parkway, Atlanta, Georgia, 30339.
Now, your local forecast, accurate and dependable from the Weather Channel. Current regional conditions. Special regional information. Your local 36-hour forecast from the National Weather Service.